Hi, I'm Z.
And I'm Jacob. The topic for our project is predicting wins in an MLB season. The goal for our project is to model a relationship between runs scored, runs allowed, and number of wins for a baseball team in an MLB season. Ways we've gone about achieving our goal are to start with a given number of runs scored and runs allowed and try and predict number of wins using that ratio. We've also gone about it by starting with the number of desired wins and runs scored to try and predict the number of runs allowed estimated, or to start with the number of desired wins and runs allowed to try and predict the needed number of runs scored. The data source that we'll be using for our project is Sean Layman's baseball database. This database includes pretty much baseball statistics dating back to the late 1800s. It includes far more data than anyone could ever need. So to narrow it down, we're going to use the team's data set specifically from 2010 to 2019. And the columns that we're most interested in are the year ID, the runs column, the runs allowed column, and the win columns. And now for methods for achieving our goal.
So here we have the piecewise linear interpolation algorithm. For the algorithm's x value, we use the RA ratio, which is the ratio of runs and runs allowed. Basically, for each data points, we divided runs over runs allowed. And the higher the RA ratio means that the team gain more points from their opponent compared to the points they lost to their opponent. And the lower RA ratio means the opposite. For the algorithm's Y values, we use each team's wins. And in terms of the implementation of the algorithm, we basically apply the same technique and calculation taught in the class. So here we have two separate data sets. The data set on the right is the data set for only the year 2010, whereas the data set on the left is the data set for the past 10 years, which is from the year 2010 to the year 2019. In both graphs, you can see that as the ratio increases, so does the wins. This is to be expected as this means that the teams gain more points compared to their opponent in their games, which contributes to their higher win rate. One of the reasons we decided to run the algorithm against these two separate cases is so that we can have a better perspective of how the ratio affects the wins. Interestingly enough, in the graph on the left, the World Series winners tends to cluster between the RA ratio of 1 to 1.2, which indicates that on average they gain more points compared to their opponent every game. Another interesting note is that the RA ratio of these two specific graphs dips at the end, which indicates that despite gaining more points in the game compared to their opponent, their wins is lesser compared to the other team with a slightly lower ratio. However, after some research, we concluded that this is just an anomaly. Another point we can observe here is that while the graph on the right does not show it, the graph on the left that includes the records of the past 10 years shows that majority of the team tends to have a ratio between 0.8 to 1.2, which means that on average, most teams have a ratio of 1. However, there seems to be a slightly more cluster between the ratio of 0.8 to 1. Here we have the results from the cubic spline interpolation. The data set shown here is the same exact data set we use for the piecewise linear interpolation. So the x values and the y values we use for this algorithm is the same as the ones we used for piecewise linear interpolation. So RA ratio is used as the x value and the team's wins is used as the y values. And the approach to implement the algorithm is the same as well. we basically implemented using techniques and calculation taught exactly in the class. The graphs here shows a very different result compared to the one we got from piecewise linear interpolation. We put the algorithm through various cases and have found that the algorithm only produces a smoother graph when the input is data set of a year, and when we input a data set that consists of 5 to 10 years, such as the graph on the left that includes the data from 10 years, the graph produces inconsistencies. We speculate that this is due to the fact that the cubic spline interpolation have trouble when there exists gaps between data points, especially large gaps between those data points, and the inaccuracy is affected when the previous data points is indicating an extreme upward or downward curve, and the algorithm tends to follows that curve and increase.
Another method of analysis we looked at was using system of linear equations, specifically partial pivoting. The steps that we took here were to first average the runs and runs allowed for each win total. What this means is we had roughly 8 or 9 data points when teams won 91 games in a season, so we averaged all those teams' runs and runs allowed totals. Then we created A matrices using the runs and runs allowed for groups of 2 win values to keep the matrices square. Then we created B matrices using groups of 2 win values as well for those associated A values. Then we found the X matrix for both the A and B matrix. And then using a target win value and some estimated run value, we could solve this system of equations for the runs allowed value. Or we could use a target win value and some estimated runs allowed value to solve the system of equations for some runs value. The following is the data that we use to produce the X matrices. On the left we have the A matrices, which are the runs and runs allowed values grouped together in groups of 2. Then in the middle we have the found X matrices. And on the right, we have the B matrices grouped in 2 that specify some win value resulting from the A matrix runs and runs allowed values. Now for some examples. So if a team scores 600 runs in a season, how many runs can they be expected to allow in order to win 91 games? When we solve for the runs allowed value using our X matrices, we find that in order to score 600 runs in a season, they would have to allow 523 runs on average. And then if a team were to allow 700 runs in a season, how many runs could they theoretically score in order to win 91 games? So now solving for the runs value instead using our X matrices, we find that they would have to score 821 runs on average to win 91 games. When it comes to making a prediction to our boss, who is the general manager of our team, we recommend using piecewise linear interpolation to predict the number of wins we will have. This is because cubic splines have trouble when there are gaps between data points and could produce incorrect predictions for those points. We recommend using the system of linear equations to predict either the runs we will need to score for the season or the runs that we could allow on the season when we have a number of wins that we are targeting. It's worth noting that the system of linear equations might be inaccurate for extreme win values such as 108 or 47 because there's only one data point for each win value. A way to go about fixing this would be to factor in more data for those extreme points. Thank you for watching, and we hope you learned something.